This is House Planning Help, episode 106. Hello, I'm Ben Adam Smith, and this is the podcast for you if you want a high-performance new home or are ready to tackle an ambitious retrofit. I'm exploring what houses we should be building in the 21st century. My personal goal is to create an energy-efficient home before I turn 40 in August 2016. Coming up in this session, my guest is Professor Phil Jones from the Welsh School of Architecture at Cardiff University. We're going to be addressing cost, performance and buildability. Some big issues there. Looking at a case study as well, not only that they've designed, but they have built and are monitoring at the moment. That to come in a few moments. We'll launch into it. A quick announcement before then. I'm very, very pleased to have been invited to an event that Ecomotive are putting on. You might remember we've actually spoken to the director of Ecomotive, that's Jackson Moulding, way back in the archive, episode 77. If you haven't heard that one, it is a good one. All about Ashley Vale Group self-build and how they wrestled a piece of land away from a developer. So I'd recommend checking that one out if you haven't heard it already. Anyway, Ecomotive are putting on a week-long series of talks and workshops, just aiming at inspiring people who want to go down this route. They want a decent home, they want decent community if they can somehow create that along the way. And then looking at some of the challenges that they will face, whether it be land, whether it be something else completely. So I'm very happy to head along there and share what I've learned over the last 3 years here at House Planning Help. So I'm going to put that into our events page. We will always have the most up-to-date events on this page, houseplanninghelp.com/events. It's Saturday, the 5th of December 2015 that I'm going to be heading along there. Also hoping to slip in a little bit about Passive House because I still think that that's one of the most significant things that you need to know about if you are creating a home. Just at least know about it. You don't have to go down that route, but I feel you'll be better off if you have at least explored it. Today, I'm chatting to Professor Phil Jones from the Welsh School of Architecture. And around the world, there are certain targets for reducing carbon emissions. I'm not sure whether they're all the same around the world. I know in Europe that there's one about zero carbon housing by 2019. So are we actually on course for that? Are we addressing it? How are we going to do it? All issues that we're going to discuss today with Phil. SOLCER House is a project that they have designed and built at the Welsh School of Architecture, and we're going to look at some of the key issues that it's hoping to solve: cost, performance, buildability, and much, much more. Let's get going. I started by asking Phil to tell me a little bit about himself.
I'm a research professor at the Welsh School of Architecture in Cardiff University. I'm a building physicist by background, and I've been working on sustainability and energy in the built environment for some time. And we work at building an urban scale. I also get involved in quite a few design projects. So I've worked on, as an environmental designer, really on a number of projects over the past 15, 20 years, mainly commercial buildings, but also smaller buildings and urban scale projects as well.
We're going to talk about the first carbon positive house that is a project that's been created there. Maybe you can explain why. Why was that what we wanted to achieve in the first place?
Well, we've been working on these ideas of low energy housing and sustainable housing for some time. And as part of our Low Carbon Research Institute, which has been up and running for about 7 or 8 years now, we've been developing a number of new technologies with industry, mainly in Wales, working with Tata on steel components, working with the timber industry, working with components. And we had the chance to design and construct a house. And the aim was to make it energy positive so that over the year it generates more energy than it uses. So we were able to bring together a number of these technologies that we were working on at a sort of research and development level into a real building. And the aim was to try and use what we've called a systems approach to integrate the technologies together and to integrate the technologies into the architecture. So the house has renewable energy. The energy demand of the house, both power and heat, has been reduced to round about passive house performance. And we incorporate energy storage for both thermal and electricity. So we were able to bring these technologies together and demonstrate in this house. So the solar electricity is used to for the lights and the small power. It's used to run the heat pump, which we use as part of the heating system. Then it charges the batteries. Then it heats hot water. If we've got any left over, then we export to the grid, which is usually in the summertime. The thermal system, we start off by bringing air into the building through a transpired solar collector, which is an air collector wall on the south elevation. When the sun is out, that preheats the air. It then comes through a mechanical ventilation heat recovery system, where it picks up some heat from the air being exhausted. And then the air is topped up with heat from a heat pump, and that's used to heat the house. So we heat the house with a ventilation system. The exhaust air comes from the wet spaces, the kitchen, the bathrooms, and that goes through the mechanical ventilation heat recovery system. So it passes some heat to the air coming into the building. And then we have the heat pump, which takes heat out of the exhaust air before it's exhausted to the outside. And that then transfers the heat to the supply air for space heating. Or if domestic hot water is needed, then it switches to providing the hot water. So it's quite a small heat pump. It's only about 450 watts, but it's quite efficient because it always works on the exhaust air, which is always at internal air temperature. So unlike an air source heat pump, which can work on outside temperatures down to below zero, which is not very efficient, our heat pump operates at a constant efficiency. So the whole thing comes together then. We optimize at this systems level. The PV panel is the roof of the building, so we don't bolt it onto an existing roof. And the solar air collector is part of the wall of the building. So we integrate the technologies together, and then we integrate them into the architecture of the building.
That obviously looks good from an architectural point of view. Renewables, though, they're gadgets that are going to break. So how will you deal with that situation down the line?
The air collector, the solar air collector, is just a metal sheet with holes in, so there's very little to go wrong. The air is pulled into the building through the mechanical ventilation heat recovery system, and these are fairly tried and tested systems now. PV systems are quite commonplace, so that shouldn't be a problem. We have batteries for electricity storage. They are lithium batteries, and now they are quite widely used. So the aim for this project really was to use off-the-shelf technologies. So we're not using anything that hasn't been tried and tested and is available through the normal supply chains.
This is buildability that we're talking about here, the ease of making it happen.
Yes, yeah. So all the components are readily available, and also we've used existing skills and contractors, all of them really local, to construct the house. So it's not that difficult. It's not. It can be constructed with the usual supply chains.
And did you have any difficulties or challenges to try and get to the standard that you were looking at with the existing supply chain?
Not really. I guess the newest product is the heating system, which combines the mechanical ventilation heat recovery with the heat pump and with the thermal water storage. That comes as a unit. It's off the shelf, but there aren't that many of them around at the moment. So that was probably the most I'd say difficult thing to source, because you couldn't get it down the local shop, so to speak. But otherwise, everything was quite easy to get hold of.
I'm certainly a person who likes the simplicity route, that anything that can make the process simpler, can take away the technology and let the building do all of the work. So I understand why producing renewable energy on site is a good idea, but there's a side of me that says, is it really the optimal place to be doing it? Isn't that what solar farms or somewhere where we've got much better control of the energy we're creating?
Well, that's a sort of top-down, I guess, view of looking at it, and then you distribute it through the usual grid structures, and that's part of the equation, if you like. I think the problem comes is when we have too much renewable energy going into the grid at a time when maybe the demand isn't there. Our approach has been to use more bottom-up way of doing things. So We generate locally, and you don't get distribution losses, for example. You don't get failures, which may be a problem in future. So you're reasonably autonomous, and we use as much of the energy in the building as possible. And that's really to also take the stress off the grid system. So at the moment, the solar PV systems on buildings tend to just push it into the grid. And I think there's a limit to how long that can go on for. So our approach is to do as much as we can locally with the energy, provide a reasonable level of autonomy, but also accepting that we will be using the grid for times that we're not generating locally, and we will be putting back into the grid. But in future, we would hope that that could be controlled so that it can take from the grid and put into the grid at the best time for the grid.
Is this also about resilience? I know that you say that these houses may need the grid at a certain stage, but presumably they have the capacity or near to the capacity to look after themselves.
They're about 75% autonomous. That's our predictions. But over the whole year, they put in roughly 70% more energy to the grid than they take out. So they're energy positive in that way. Of course, when the sun doesn't shine, because these houses rely mainly on solar renewables, we have to take from the grid. So there will be times in the winter when we are, relying on the grid when the sun doesn't shine for a few days and the batteries run flat.
Can I go back to collection for a moment? Because that's been one of the big challenges in the past, and I don't know whether things are getting better. You mentioned a lithium battery, but as far as I can understand, these things are quite clunky, they're big. So how is that technology coming along?
It's developing at a fast pace, really. When we first started to design the house, which was just over a year ago, we're going to use lead-acid batteries. We were worried about weight and safety. We beefed up the structure of the roof space because that's where we were planned to put them. And they were going to sit on the floor. Lead-acid batteries, you can only discharge them to about 50% of their capacity. Otherwise, you reduce their lifetime. So even though they are of a particular size, really the capacity is half that. Lithium, on the other hand, is much lighter. You can discharge them to about 20% of their capacity. So even though they were more expensive, for the same size of battery, you had more capacity to work with. And so the cost was coming down at the time. So we went for lithium. They bolt to the wall. They're not particularly heavy. They're quite neat and tidy and don't need any real sort of maintenance or anything, from the occupants. And since we've put the batteries in our house, they've come down in price again. Probably, I think we can get them now for half the price that we paid. Tesla are now bringing out, they have a battery that they market for housing, and I think it's around about 7 kilowatt hours, and that's around about £3,500, I think. The costs are predicted to come down even further.
And the lifespan?
Well, that remains to be seen. We expect to get a reasonable use out of them, and we're hoping for about 10 years, but that remains to be, that's one of the things we need to be looking at, of course. At the moment, I don't think it's very easy to recycle them, but it is possible to recycle them, but at a cost. But I'm sure these costs will come down and as the technologies develop.
So this project, one of the key factors was all about cost. We've talked about buildability. How else have you been able to keep the costs low?
Well, some things have cost more. The heating system has cost more. The battery systems, for example, they add on costs. But we are able to save costs as well. We don't have a wet heating system, so we don't have radiators. We heat with the ventilation system. So that reduces costs and it reduces wet services around the building. Also, it creates more space. In houses, radiators are often inhibit space use. So we've got far more flexibility of space use. The PV panel, because it's a roof as well as the panel, it fulfills two purposes. So the PV roof is not that much more expensive than a normal roof. The air collector is part of the wall construction. So there are certain costs that have offset other costs. So cost increases have been offset by cost reductions. So we think we can bring the cost of this in at around about the price of a standard social house, or the price of something that's produced by a quality private developer. We're not competing with the mass house builders because they build at a very low cost, but we're aiming for quality and provide something that doesn't cost the occupiers much, if at all, in energy.
And talking about those running costs, do you have an example? Because I have a feeling there's no one living in it, is there?
Well, we occupy the building.
Oh, okay, I'm wrong.
But not as a house. So it's occupied every day. We have office-type activities going on there. We use it as a meeting place. I'm usually there a couple of times a week. So it is heated, and we are sort of aware of the conditions inside, and we're monitoring it. The aim first is to test the technology and its integration into the architecture. So we're monitoring the building quite closely to assess the performance of the various pieces of equipment. We then plan to carry out simulated occupancy to get a better idea of how it performs with day and night occupancy, with using the cookers and small power, but also drawing off hot water, etc. So we are planning to do that to see what the energy use is likely to be, or the energy performance under normal occupancy.
How much of this is about ticking all these boxes, making it affordable, make it perform well and buildable, and how much is actually about creating something that's architecturally going to work, perhaps on a bigger scale?
Well, the idea is that it can be replicated. It was designed as a social for social housing. It's 100 square meters, so it's quite generous spatially. But a lot of private developers have been interested in it as well. So the idea is that it can be replicated. The architecture of the building, it turns out to be a result of bringing together and optimizing at this systems level both the technology and the building construction. Some people think the aesthetic is good. Most of the general public who come there, and we've had hundreds of people come on open days and have seen it on the internet, I don't think we've had any negative response. It's been extraordinary, the amount of support that we've had. So generally people like it as it is, but the principles that we're using can be adjusted to suit different aesthetics. It can also be adjusted to suit different building types. The system that we're using would be particularly good for schools or care homes, for example, or even commercial buildings, industrial buildings. So I think what we have is something that's replicable at scale in terms of housing and to other building types.
Can you talk through the construction then and exactly what is in the fabric?
Well, we've used the SIPS panel construction, which is 2 layers of timber with insulation bonded between. That's cut off-site, so it's delivered off-site as a sort of flat pack, so it's easy to construct. The south-facing roof is a PV panel. The north-facing roof is a standing seam metal panel. That's smaller than the south-facing. The roof is biased towards the south. There's a render applied to the outside, except where the thermal air collector is, which is a metal cladding, really. The windows, we've worked quite a bit with big industries. NSG Pilkington's helped us a lot with the glazing systems and with the glass of the PV roof. BASF have been supporting us because they provide the sort of thermal insulation and the renders and the paints. Tata Steel have been supporting us. They provide the transpired solar collector, and we've been working with them for about 6 or 7 years on these technologies. So the construction methods are fairly standard, but we have had a lot of interest from big industries as well as the small local suppliers. The construction program itself took 16 weeks from start to finish. If you go into YouTube and type in SOLCER House, you can see the whole process.
We'll link it in the show notes as well, so we can see some of that. It's quite interesting to hear you talk about, did you start designing it little over 18 months ago and then complete it all in this short space of time? And why? What do you accredit that to?
Well, we knew what we wanted to do. We've been working in this field for some time. We've designed and constructed other buildings. If you go back to around about 2000, we did the first BREEAM Excellent industrial building on the Baglan Energy Park in Port Talbot. And that was a building that integrated PV renewables into the facade. We worked with Tata and the Welsh Government, and we designed and constructed a research centre up at Shotton in North Wales, where again we were looking at integrating renewables into a low-energy building design. And that has been the centre where we've carried out the research into some of these areas as well. So we've had a history of doing things. So we knew the sort of technologies that we wanted to optimize into this process. So it's really not optimizing at a component level, it's optimizing at a systems level and accepting that some of the components may not be fully optimized at this point in time. But it's only when you put things into a system that you really start to make the benefits in performance and cost and reliability, etc. So we had some funding through the Wales European Funding Office, structural funds, and we convinced the funder that this was a good project to do. We designed it fairly quickly, and we had to spend the money fairly quickly, so that was an incentive to get it done, as with all these sort of projects. So we took control of the construction ourselves. So rather than going out for a turnkey sort of solution, we managed the project, but we appointed a construction manager on site to manage the contractors and the site work. So it worked out really well because we were able to keep control over the project, not to be persuaded to change things for various reasons, which I think might have happened had we gone out to just one contractor. And also we were able to keep an eye on the costs and to make sure that we kept within budgets, or that we understood the budgets. So it was a good experience. So the 16 weeks was with us doing it, and we're not house builders. If a professional house builder took up these ideas, they could probably reduce that time considerably.
Let's just hang on that for a second. Professional house builders, as you've already mentioned, work to a very low budget. Why are they not trying to embrace better ways of building?
Well, I think there are three types of house builder. One is the mass house builders who follow the building regulations and don't want to change. They won't do anything new until they have to. They have standard house types. They have a culture. They have a product that they sell. And this isn't that product. They could do it, and they could probably do it for not much difference in cost. They choose not to. And they actually resist change. So they tend to not be supportive towards any change in building regulations, for example. So, but they produce a product, and although they've been to see the house, they're interested. I don't think it's something that they will do at the present time. The social housing, who have a responsibility to the tenants, there's issues of fuel poverty, and they tend to build at a slightly higher cost. They're interested because it's not just about the cost of the house, it's about the performance over time and giving people a house that they can afford to live in into the future. So they're interested. The smaller scale developers, I think, see this as a market opportunity. I said there's a huge response from the public saying, why can't we have this sort of house? And I think that these small scale developers will come into the market and provide that demand. Because there is a demand for these houses. People who see it want it, and they are slightly confused about why all houses can't perform like this.
Finally, then, what have you learnt through going through this whole process, or would do differently?
Well, what would we do differently? What we've been learning is the way of doing things from the supply chains. So we work very closely with the supply chains. They've got the benefits of working on this project, and some of them are now replicating it on other buildings. So they're able to get work because they've got this background now. And we've learned from them about the difficulties or whatever issues there are. I think we're 90%, over 90% there in what we set out to achieve. There are details that we would change, but they're usually very minor and often aesthetic. We will be monitoring the building over this heating season and into the future, and we will be looking closely at the performance. And we do expect to see areas where we can improve things to further, improve the performance. At the moment, we're just going into this heating season. The initial results from the components are good, but I suspect that there will be areas. I hope there'll be areas where we can get further improvements.
Phil, thank you very much.
Thank you very much. Thanks.
With every interview, we provide online show notes. Today at houseplanninghelp.com 106. We've got a summary of what we've learnt. We have some photos of SOLCER House, and we go into more detail as well. If you want to, you can download their brochure. Links to Phil, links to the Welsh School of Architecture, and if you have a comment or you want to ask a question, you can do that at the bottom of the show notes, houseplanninghelp.com/106. That's just about it for today. I will give you a hub update before I check out. And this is a new video that we've added about Long Barrow Passive House. We've been filming there for the last 11 months. You've probably heard Alex Baines on the podcast a few times as well. He's the self-builder behind it. And we're just producing different chapters of the story, trying to go in detail on some of the decisions that have been made. It's often good to talk about it in a podcast, but you can't show the visuals, can you? You can't see what's going on, and that sometimes makes things clearer. So that's what we're aiming to do, one of the big benefits of the hub. So we've got an introduction to the project, that's one of the videos, and also one on the dig at the moment. We'll be adding more over time, as I mentioned. Also, some of the other benefits of the hub. Each month, we're going to be adding a new module that will go in depth on not just UK issues, but I think to begin with, that's going to be our unique selling point, that we have to start somewhere. So we're going in depth with some of the things that we can't cover on the podcast. And also there's a forum there. So if you're building a house, you can network with other people who are doing exactly the same. You can ask questions, which we will try to answer the most frequent ones. In the early days, this will hopefully be quite easy, but as there are more people in there, it might get more of a challenge. And this is all at the bargain price for now of £45 a year. So go and check it out, houseplanninghelp.com/hub. And we've also got some free courses if you just want to see, what is this all about? That will just give you a taster of what is to come in the hub. Thank you very much for listening this far again. I do appreciate your company. I hope you enjoy what we produce, and we always love your feedback too. The House Planning Help podcast is produced by Regen Media, content that matters.